So now let's take a look at number 21, right? Number 21, we have a system of equations, right? We got two equations. We got 2 to the x plus 3y power equals 8 to the fifth power. And we got 3 to the 2x plus 5y power equals 27 to the negative third power. What you want to do in this problem is you want to eliminate the exponents, right? By creating equations based on just the exponents. You want to create equations based just on the exponents. But before you do that, all your bases got to be the same. So notice that this base is 2 over here, just in the first equation. Let's just look at the first equation. So this base is 2, this base is 8. We can't really work with that. We got to fix that. What we can do with the 8 is we can change it to 2 to the third power. And now our bases are the same. So we had a base of 2 on the left side of the equal sign. Now we got a base of 2 on the right side of the equal sign. So 2 over here, 2 over here. But it's not just 2. 8 is the same thing as 2 to the third power because 2 times 2 times 2 equals 8. So we put this in parentheses, right, to show that it used to be an 8. And then the exponent 5 is still there, but it's outside the parentheses, right? And then eventually we're going to use the power of a power rule, right, in order to simplify that. So then we do the same thing with this equation down here. We got 3 to the 2x plus 5y power is equal to 27 to the negative 3. Our bases are different right now. Our bases are different, but we're going to make it the same by changing 27 into 3 to the third power. That's just something you just got to become familiar with and just know that 27 is equal to 3 to the third power, right? So 3 to the third power is in the parentheses, and where does this negative 3 come from? It was already there. That was the 27's original exponent. So that's still got to be in the situation. You can't just drop that and get rid of it. It's still part of the conversation, right? So now you can create equations with no exponents, right? Just based on the exponent. So we use this. In the first equation, we're going to have x plus 3y is equal to not 5, but actually 15. Because remember, we got to do 3 times 5, use the power of a power rule. Now that's really 2 to the 15th power. So we got x plus 3y equals 15. That's going to be our first equation right here, right? Now, where did 15 come from? You got to multiply these exponents. Right? So now we just got 2 to the 15th power. So you create an equation just based on the exponents. X plus 3y is equal to 15. And in the bottom equation, same thing. 2x plus 5y is equal to negative 9. Where did negative 9 come from? 3 times negative 3 is negative 9. So that's why we got this equation. So now we got a regular system of equations that you probably learned how to do in like an algebra 1, maybe an algebra 2 class, right? So, and there's options for this. We could use the substitution method. We could use the graphing method. I don't recommend the graphing method for a problem like this though. We could use the elimination method. Some textbooks call it the addition method because you added both equations to each other, the top to the bottom. Or you could use matrices or Kramer's rule or whatever. I chose to use the elimination method. So what I did is I wanted to change this x right here into a negative 2x. Why did I want to do that? Because then that helps me to eliminate the x variable. Eliminate it. And then I end up with an equation. When I add this top equation to the bottom, I end up with an equation that only has one variable in it, just the y, right? So I got negative 2 times everything, but you can't just multiply the negative 2 by the x. You got to multiply the negative 2 by everything, right? So we got negative 2 times x, negative 2 times 3y, negative 2 times 15, right? Negative 2 gets multiplied by everything in that equation, right? Your bottom equation, I'm not changing that. I'm not messing with that. I'm leaving that alone because I don't need to change it. So we got negative 2x minus 6y equals negative 30. Right? Because everything got multiplied by negative 2. This, and this, right? Now, you don't just multiply the thing you want to change. You got to multiply everything to keep the equation consistent, all right? And then the bottom equation didn't change, so I got 2x plus 5y equals negative 9. Then we add these together, because that's why some textbooks call this the addition method, because you add the top equation to the bottom equation, right? But the goal is to eliminate one of the variables. That's why some textbooks call it the elimination method. And that's why I call it the elimination method. I just like that. So negative 2x plus 2x is 0. You see the x's got eliminated. Then negative 6y plus 5y is negative y. And then negative 30 plus negative 9 is negative 39, right? So now we got negative y equals negative 39. We're not done yet, though, because we're trying to solve for y, not negative y. We want to know what positive y is. So to get rid of this negative 1 coefficient, because that's what a negative sign means when it's in front of a variable, a negative 1. negative y divided by negative 1 is positive y. And then negative 39 divided by negative 1 is positive 39. So our value for y is 39. Now we got to solve for x because it's a system. Remember, we got to find out what x and y is. So we go back, you could pick either one of these equations. It don't matter which one, the top one, the bottom one, the first one, the second one. It don't even matter. I just picked the first one. It just seemed like it was easier to work with. So we got x plus 3 times 39. Why 3 times 39? Because that said 3y. And we're saying that y is 39. So if y is 39, then I can replace the y with a 39. And that's what I'm doing. So x plus 3 times 39 equals 15. So then I do 3 times 39. I do the math. 3 times 30 is 90. 3 times 9 is 27. 90 plus 27 is 117. We got x plus 117 equals 15. And then we got x equals 15 minus 117. So then we got x equals negative 102. Right? X equals negative 102. So that's our x value. Our x value is, or our solution is negative 102 and 39. X value, y value, follows alphabetical order. And if you wanted to, you can go back and check your work, go back to the original drawing and just replace the x with a negative 102, replace the y with a 39. And then what's going to happen is you're going to have, I think, negative 102, and that's going to be 117. So that's going to be 15. That's going to be 2 to the 15th power, which is true because if this is 2 to the 15th power, that was 2 to the 15th power. So that's true for the first equation. Now with the second equation, we do 2 times negative 102. That's negative 204. I did the math right here. So that's convenient. So we got, end up with negative 204 plus 195 because 5 times 39 is 195. So negative 204 plus 195 is negative 9. So that's like saying 3 to the negative 9 power is equal to 3 to the negative 9 power. So that's proof that that's correct. So this is just a little something. It's just a system of equations problem. If they gave this to you, this is like an algebra 1 question right here. But they tried to get like a little bit like freaky with it and see if you really understood how to use the what are the properties for solving exponential equations. I can't remember what the specific name for this is, but this is one of the things we have to do when we deal with exponents and actually logarithms too, which are the inverse of exponents. You just got to know to make your bases the same. Once you make your bases the same, you can create a separate equation based on just the exponents, right? But this, let me warn you though, you can't just say x plus 3y equals 5 because that ain't true. That ain't even true because it's only true that the exponents are equal to each other if the bases are the same. See, right now this is a 2 and this is an 8, but that's why I had to flip this 8 and turn it into 2 to the 3rd power. I had to switch them up, right? And you can't just say 2x plus 5y equals negative 3 because the base is not the same. Until the bases are the same, you know what I'm saying? You gotta make the bases the same. So that's why I had to change 27. I had to flip that and make it 3 to the 3rd power, right? Then I could create the equations with the exponents. Do my 2x plus 5y equals negative 9, not negative 3, negative 9. Because remember, you gotta multiply these exponents together. And then x plus 3y equals 15 because you gotta multiply these exponents together. You know, so I hope that helps.